Okay, moving on, we want to be able to add or subtract complex numbers. This is really easy to do. All we have to do is add the real parts together and then add the complex parts together. So what I mean by that is I just add 5 and negative 7, which I know is negative 2. Then I add negative 6 and negative 2i, which ends up being negative 8i. And there it is. It's simplified. For multiplication, in number 15, you do a similar thing. You just have to make sure you distribute. So I have 2 times 1, which is 2. I have 2 times negative 4i, which would be negative 8i. Then I have a 3i times 1, which is 3i. And then lastly, I have 3i times negative 4, which ends up being a negative 12i squared. At this point, I have to figure out, wait a minute, negative 12i squared is the same as saying negative 12i squared we already said was negative 1. So that ends up being positive 12. Okay, so I end up with 2 minus 8i plus 3i plus 12. So when I add those together, I have 2 plus 12 is 14, and then negative 8i plus 3i is minus 5i, and there it is. Alright, now to divide, it's a similar thing. I just have to add one more step. I need to get rid of this denominator, and the way I do that is by multiplying the conjugate. And the conjugate is the denominator, you just change the sign in the middle. So I multiply by 1 minus I. Okay, so the conjugate to a plus bi is a minus bi. Alright, so that would be, in the numerator, let's just leave that as 2 times 1 minus I. In the denominator, I need to distribute. So when I distribute here, I have 1 times 1 on the outside. In the first. The outside, I have 1 times negative I. On the inside, I have I times 1. And lastly, I have I times negative I, which is negative I squared. Okay? And we can think about it for a little bit. Negative I squared is the same thing as negative 1, which ends up being positive 1. Okay, so I end up then with, notice your I terms cancel out, and they'll always do that for the conjugate. And I end up with 1 plus 1 here, which ends up being 2. So I end up with 2 times 1 minus I divided by 2, and thankfully the 2's cancel, and so I end up with, as an answer, 1 minus I as my final answer. Okay, let's look at some equations. So these are going to be linear equations, and we have some variance on them. And remember, the strategy for linear equations is you got to get x on one side and everything else on the other. So this first one, I'm going to distribute. I have a 3x plus 5 equals distributing the 3 here. I got 3x plus 9 minus 5. So I end up with 3x plus 5 equals 3x plus 4. And I think this is going to be a problem because when I move the 3x from the right to the left, I end up with 0. And when I move the 5 over, I end up with negative 1. That can't happen, right? So what's going on here? We have a contradictory equation. We have no solutions. Okay, so if you end up with a nonsense statement, you have an equation with no solutions. Moving on to 18, hopefully these are not all nonsense. Let's see here. If I distribute the negative 3, I end up with negative 6x plus 12. On the other side, I end up with 7 minus 7x. Okay, now moving the x over from this negative 7 over from the left to the right, I end up with a positive x over here because I added 7. And when I subtract 12 from both sides, I end up with a negative 5. And so there's my solution, x equals negative 5. And you can test this if you want by plugging negative 5 back into the original and seeing if you end up with an identity, something equal to itself. Okay, number 19. This time we have an absolute value situation. And so if you remember back to our absolute value situation earlier, we have to go back to this definition. The absolute value here, so here's 0. Let's say I had an absolute value of 6, for example. That means I could go 6 in this direction or in this direction and still have an absolute value of 6. So negative 6 and 6 both have the same absolute value. And so when I go to this equation and I'm trying to solve for when does this absolute value have absolute value of 3, I need to consider two equations. 4x plus 15 equals 3 and 4x plus 15 equals negative 3. Okay, so from the first one, I subtract the 15 over, and then I just divide by 4. So I end up with x equals negative 3. And the second one, I subtract the 15 over, and I said divide by 3 earlier. I mean I divide by 4, so get negative 18 fourths, which would be negative 9 halves. So as a solution, I say I have negative 3 and negative 9 halves as my solution. Okay, number 20. I want to clear my denominators here. I don't like the denominator, so what I'm going to do here is I'm going to multiply, to get rid of the 4, I'm going to multiply both sides by 4. And to get rid of the 6, I'm going to multiply both sides by 6. And the result of this is on the left-hand side, when I'm multiplied by 4, the 4 in the numerator and the 4 in the denominator will cancel. And on the left-hand side, the right-hand side, the 6's cancel. So what I end up with now is simply 6 times y plus 5 equals 4 times 1 minus 5y, which is linear and a lot easier to handle. So I have 6y plus 30 equals 4 minus 20y. Okay, so then adding the 20y to both sides, end up with 26y, and subtracting the 30 from both sides, end up with negative 26. So y ends up being negative 1. Alright, now looking at number 21, this is an absolute value situation again. And this time we have two absolute values, but don't worry, it's not too bad. What you have to do is when you drop your absolute value, you need to consider x minus 4 equals a positive 2x plus 1. Or you have to consider x minus 4 equals a negative times 2x plus 1. Okay, and then the reasoning is the same as before. Here, when I had it equal to 3, I had to consider when it's positive and negative 3. And now at 21, it's the same situation. Okay, so in the first side, I subtract over the 2x, end up with negative x equals, bring over the positive 4, I get negative x equals 5, or x equals negative 5. And on the other side, remember I distributed the negative, so I have x minus 4 equals negative 2x minus 1. I add over the negative 2x, end up with 3x on the left, and on the right, I end up with 3, because I added negative 1 plus 4, which means I get x equals 1. So my solution then for this is negative 5 and 1. That's my solution. So in this next one, I need to isolate my absolute value, so I subtract over the 5, end up with a negative 2. And here I notice, wait a minute, absolute value can't be negative. Okay, so I automatically know this has no solution because an absolute value cannot result in a negative number. But if you hadn't noticed that, watch what happens. I have 6x minus 7 equals negative 2, or possibly 6x minus 7 equals a positive 2. So in the first case, I end up with 6x equals 5, or x equals 5/6. In the second case, I add over a 7, I get 6x equals 9, or x equals 3. And if you plug these back in, you'll notice, for example, if I plug in 3 back into my original, I have 6 times 3, which is 18, minus 7, okay, an absolute value. So that is what? That's 11, plus 5, and that does not equal 3, right? So I ended up with a contradiction. So both of these result in contradictory answers. Okay, so it's no solution. Alright, now we're going to move on to linear inequalities. And so that's where we have what I like to call the alligators. Alright, so first of all, I need to get the strategy the same as linear equations. You get all the x's on one side. So I'm going to distribute my x here. I have 5 minus 2x plus 6 is less than or equal to negative 1 plus x. Okay, so I'm going to bring over, let's see, I'm going to subtract over an x to get negative 3x. And then I have an 11, which I'm going to bring over to the other side to get negative 12. And then when I divide by negative 3, I need to flip my sign. And why do I do that? Remember, divide by a negative results in a flipped sign. Okay? So here I end up with x is greater than or equal to 4, which on a number line would look like here's 4, 4 is included, and I need the bigger part. Okay, so in interval notation, that means the smallest thing I can have is 4, which is included, and I end up at infinity, and which is never included, so I end up with a parenthesis on that. So here at 24, I have a similar expression. This time it's called a compound inequality. In other words, I have 2 alligators, but that's okay. I just need to get the x by itself, so I subtract 3 from everything. So I end up with negative 4 less than 2x less than or equal to 2. And then I divide everything by negative 2. Dividing by negative 2 means I need to flip my sign. So negative 4 divided by negative 2, and a 2 divided by negative 2. So I end up with this expression. Now on a number line, that means I have negative 1 and 2. The negative 1 is included, 2 is not. And notice x is greater than negative 1, but simultaneously less than 2. So you end up with this portion of the number line. Which then would be negative 1 to 2 parentheses, because the parentheses on the 2 because it's not included. Alright, now looking at number 25, we have the absolute value of 3y minus 2 plus 2 is less than or equal to 6. So the first thing I want to do again is I want to isolate my absolute value. So that's going to be less than or equal to 4. Okay, now dropping the absolute value, remember that means that my absolute value is less than or equal, is between 4 and negative 4. Remember you have to consider the positive and the negative case. So here I have, you can write it like this. 3y minus 2 is between negative 4 and 4. And some students have mentioned that they would prefer me to write it like this. 3y minus 2 is less than 4, or 3y minus 2 is greater than or equal to negative 4. And you can do that. It's saying the same thing, okay? So over here I'm going to add 2 to everything. So I have negative 2 plus 2, that's negative 4 plus 2, that's negative 2. And 4 plus 2 gives me 6. So y is between negative 2/3 and 6 divided by 3, which is 2. Okay, so on a number line, that's negative 2/3 to 2. Both are included, and I'm in between the 2. So as an interval notation, I go negative 2/3 to 2, and they both get brackets. And there's my solution. Okay, this last one, number 26, I have the absolute value of 4 minus 2x is greater than 6. Okay, so the greater than doesn't mean that we're trapped in the middle like these last couple. It means that we're actually pushed on the outside. So the absolute values being greater than would be these parts out here, for example. Okay, so what that means then is when I want to drop the absolute value, I'm going to have 4 minus 2x is greater than 6, or 4 minus 2x is less than negative 6. Okay, so now when I subtract 4 from both sides, I get negative 2x is greater than 2. So that means x is less than negative 1. On the other side, I have negative 2x is less than negative 10 for subtracting 4 on both sides. Then when I divide by 2, that's greater than 5. And remember, I have to flip my negatives. Why? Because I'm dividing by a negative, right? So I flip my sign because I'm dividing by a negative. So this time, if you look at the number line, here's negative 1, here's 5. Neither included. And this says less than negative 1 and greater than 5. So I'm out here in these tails like this. In interval notation, you write this first interval as negative infinity to negative 1, the second one of 5 to infinity, and then to show that they're together, you union them together like this. And that would be my solution. Okay, I have now worked through 26 college algebra questions, and I hope this helps prepare you for a test. If you have any questions, please let me know. I'd be glad to answer. Sorry I rushed through these so quickly, but again, I hope it's useful. Thanks for watching.